If you are bored, couldn't you be working on LTF number 2 odds? Or LTF number 1 evens? Or just LTF number 1 odds because you haven't even done the homework. Okay, and if you're not bored, listen up because I'm ready to answer whatever you have, except I'm so sorry, Naomi, you are leaving for something. Did you already know? Yes. Is anybody else going to be gone tomorrow and they already know it? Does everybody just want LTF number 3 just for the heck of it? Yeah? Yeah, LTF number 2, sorry. Isa found out that it was copied horribly wrong. I don't know what happened, just something bad. So then we'll just have no bonus for LTF number 2. And I'll try to get you guys the extra. Because logistic growth, AP Chem saw that recently. No, AP Bio saw that recently. And Euler's method, we had an Euler's method on one of the mock APs. It didn't go well. Anyway. Yeah. Did you guys both have Euler's method? No, we had it at most. Oh. All right. Yes. Okay, let's start with odds first. Odds, I'm ready to go. Justin, what do you got? 7. Anything before 7? 3. Anything before 3? AKA number 1? Okay. Number 3 is a non-graphing calculator. Oh, and it's a beast.
We all got B. I mean,
Okay, focus. Write the first 4 non-zero terms in the general term of the Taylor series for g of x about. Who is g of x? This dude. What dude? This guy who starts with g of 0, but they all start with negative 1. Well, that's no fun. Okay, can we just go ahead and write it out? Are we cool? X minus 0, it's centered about 0, right? Cool. Have you guys noticed that it can say at or about? Have you noticed that? At, about, around, all means the same thing. Okay, g double prime of 0 all over 2 factorial times x squared plus first 4 non-zero terms, 1, 2, 3. I'm hoping I find a pattern if it goes any further than this. Okay. Plugging into the derivative, if we plug in g prime, that'd be the first derivative, right? It'd be 1 factorial times, let's see, g of, got it. Okay, 1 factorial is just 1, 1 plus 1 is 2, 2 over 2/3, right? G double prime, because it's 1 factorial, which is 1, 1 plus 1 is 2, and 3 to the 1 is 3, so 2 over 3. And then G double prime will be 2 factorial, 2 times 1. Here you go. And then 2 factorial times 3 plus x factorial times 3 plus 1 is 4, all over 3 cubed, which is 27. And I'm guessing they don't simplify. I guess I didn't need to do all that work.
The answer is A. That's the problem. Are you sure? Yeah. I mean, maybe I'm wrong.
Yeah, it says the answer is A.
Yeah.
Well, I didn't keep going, so the 3 over 9 would be 1 over 3 and 2 over...
They literally have it without the factorials.
What?
Oh, Kathy got A. Let's Kathy go.
Oh,
Because 3 reduces to 1 at 3.
Yeah.
because after you do the derivative, you have to divide by the 2 factorial, 3 factorial, and so that cancels with the factorial on top.
I hear you saying derivative, but then I don't see a derivative.
Like g to the n.
Oh, thank you. Thank you, thank you. I made your guys' mistakes. Lame. All over, that would be 1 factorial, that would be 2 factorial, that would be 3 factorial. We didn't plug it into our... I got stuck by the most common trick in the book. That's lame. So we have to remember, the derivative is only... No. The derivative is only one part of the formula, true? And that's important for going backwards too, which I would have caught that one. I just didn't catch this one. Okay, now number 7. Oh, just kidding, 5. Number 5. Thanks, Kathy. And Arian. What is number 5? Oh, here he is. Second degree Taylor polynomial. What does that mean, second degree? Second derivative, x to the second power. True? Okay, so second degree polynomial approximation of h. So don't I need h of 0 plus h prime? Guys, I don't know about you, but I need to write it out. Because as you just saw, I make mistakes. Okay, that would be the second degree, I believe. Let's check it out. H is equal to g of x squared. So shouldn't I maybe start with g? Right? Well, hold on. G of x has a Taylor polynomial as defined by what you have, right? And so if we were to do, I don't see any derivatives or integrals, so let's just go ahead and stop at the squared again. For the second degree Taylor polynomial? Okay, what did it end up being? Was it 3/9? No. Yeah, which is why there aren't too many multiple choice that are built upon each other. Yeah, for h, I can go ahead and say it's going to be g of, which is going to have of -1 plus 2/3 x squared plus 3/9 x squared squared. But they asked for the second degree Taylor polynomial, so I'm not going to include the x to the fourth. I'm going to stop right there, which is why I would go ahead and put it as e. Why are there approximates? This is a truncated polynomial, right? Which means it's not the entire infinite, so it's not going to be converging. Is that okay? This is on the video too, if you guys want to check it out later. 7. Okay, so I would, on this one is specific. There's something plugged in. It's very similar to like a definition of derivative problem with the x plugged in. You got to think about it before and then plug in. I don't know if that rings any bells, but we were doing definition of derivative in Calc AB this morning. By the way, in your guys' exam prep folder, in your AP exam prep folder, there is a folder for laying the foundation reviews, and actually I have all your reviews in there. I also have a folder of Calc AB reviews, just if you guys do want to go back and look at any topics. I know some of you have your packets from last year, but some of you didn't have me last year. All the 12 AB reviews that are like this are in your class folder under AP exam prep. But coming back, so I would look at this and say, okay, hold on. Does this match up with anything if I have x minus, what do I have? X squared over 2 plus, oh, did they tell you something earlier? So this is f of x? Did they tell you what it was? Like what special Maclaurin it went with? Oh, okay. Okay. But L1 plus x, we've already established that. Does that make sense? Okay. So then if that's true, can't I just see that this is the exact same series with the 1 plugged in? So I can think for this entire thing such that x is 1/2. So then all I have to do, Justin, is just plug in 1/2. And then we have it. I believe. Yeah. So it was just identifying that the x was 1/2, and then I could plug in chug. Maggie. Since they're so built on each other, yeah, we'll cover both. Yeah. Have we missed any evens along the way? Sorry, did I skip over anyone's questions? Okay. So number 8. Guys, wording. Wording. What does it say? Okay, what should our brain jump to? Lagrange. And if there's no clues for Lagrange, I guess we could be finding like a ratio test with the error, the old-fashioned error if it's an alternating series, and then we could be maximizing like an actual function for error. So either we're finding the max of like some sort of ratio test error, alternating series remainder theorem. or we're doing Lagrange. So let's go look at our clues. Do we have an alternating series, yes or no? Because for Lagrange, wouldn't we need to have a clue about the max, not just what it is at the point, but the max? And I don't see any less than or equal to. I don't see any like a function for the derivative that I can actually find. I guess we could find that derivative and then find its max. Shh, whisper, 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 whisper.
If I was to do Lagrange, I set up Lagrange, but I didn't.
Although I told you who f was, so we could technically, what? 7th degree. Ooh, 7th degree.
So that's why I tried, but I didn't know what to put.
Yeah, I think I would go 8th too. Why are you doing 8th? Because when you're doing Lagrange or you're doing the alternating series remainder, you're going to the m plus first term, right? And so what would have been, what would have been the actual 8th? Okay, following the pattern. 8 factorial or just 8? Just 8, right? Okay. So if I'm trying to do a sub n plus 1 all over a sub n. No. Sorry. Me and the ratio test. And I'm doing this such that x equals 1, right? Okay. Then I can say that the error is going to be less than or equal to negative 1 to the 8th all over 8.
Oh, so this is not.
However, I believe it's absolute value for both Lagrange and alternating series remainder theorem. Yeah. If they had given me a Lagrange clue, I would have gone that route, but there literally was nothing to tell me about the derivative without me finding the 8th derivative of ln of 1 plus x, and I frankly just wasn't.
Can you only use that type of
For alternating series. Yeah, the alternating series remainder theorem. Which Lagrange is similar, but not quite as basic. Okay, what else do we have? Evens or odds? It's all blue. Hold on. Blue screen of death. Just kidding. I hope. Uh-oh. Okay. Sorry, number which one?
Number 13. I mean, number 14.
Anything before number 14? Sorry, we're jumping.
Like you just do like 1 minus.
Okay. Okay. I think I got back my graphing calculator today because this is a GC. You guys got that from yesterday, right? Okay. We want to use the Maclaurin series to estimate e to the x. Well, okay, we better start there. So who is e to the x as a Maclaurin? Because the derivative of e to the x is e to the x, and if you're plugging in 0, the derivative is always 1. So we just think, if that helps you guys as far as memorizing. We want to use the Maclaurin series to estimate e to the x on the interval 1 to 2. It's centered at 0. Which of the following would be the smallest integer value for m in the remainder theorem? You guys know it's not alternating, right? So if it's not alternating, this must somehow be using Lagrange. True? Smallest for the remainder theorem. Oh, okay. I'm just putting it not on the tray. Is that okay? X to the n plus 1 over n plus 1. So if we're thinking of Lagrange, that's f to the n plus 1 I'm annoying myself. Right? Okay. So we have x to the n plus 1 right there. We have n plus 1 factorial right there. So what are they actually asking for? This is like so many AP problems where they give you a random variable in a spot and you have to determine what it was or what it is. The max of n plus first derivative. Does that make sense? So f of n plus 1, I want to find the max of the n plus first derivative. But hold on. What's my function? What's all the derivatives of e to the x? Oh, so aren't they really just saying find the max of e to the x? Infinity. Wait. What interval? 1 to 2. Well, if e to the x is increasing, where is e to the x the highest? 2. So e squared. Well, I don't know what e is. The smallest, no, you don't have to. The smallest integer value. Don't die. The smallest integer value. Well, 2.7, I mean, that's not going to work, right? You can always do 2.5 times 2.5 if you want to be really lazy to get an idea of what's going on. That's gross. Isn't 25 fourths, isn't that 6 and a fourth, and that's even less than that? Now what? You could, or I did a lower bound. What's an upper bound? Well, but that's 9. Yeah, it would be good, but it doesn't help us. How about 2.75? Wouldn't that be an upper bound? Why am I doing 2.75? Because it's an easy fraction. Well, it's not great, but wouldn't that be 2 3/4, which is the same thing as 11 fourths? And 11 fourths squared would be 121/16. I know it's not great, but... Oh, lo siento. But never mind. What's e squared? Well, it's not awful because you could have just plugged in and seen 7.389. Never mind. I know. No, it's okay. Well, we would have gotten there because I totally would have gotten something that was... But anyway, thank you. I appreciate it. Yeah. Ooh. I was just tutoring Bridget before her last test.
So is this the same thing as the interval convergence? Radius is half of the interval convergence, right?
Yeah, radius is half of the interval of convergence. But wait a minute, what form is this? It's a geoseries. It's a1 over 1 minus r. Do we see it? Geoseries. We like geoseries because we know the interval of convergence, that's a C, is the same thing as r is in between -1 and 1. True? So can't I just take the r, which is -2x, without even thinking super hard about the series, etc., and just solve? Yeah, so you can cut everything in half, technically -half. The distance between that is 1. And half of 1 is b, right? Oh, okay. I thought you said E or D, and I was like, neither of those are even close. Okay. Yeah. Yeah. Let's talk through. Below is the graph of f, where f is at least twice differentiable, and f forms a triangle. Only here, though, right? That's not triangular. That's not triangular. Also suppose that, that's important, And that's important. Wouldn't G prime be roughly F? Like the fundamental theorem of calculus, if they put these bounds on there? And then G double prime would be F prime? And G triple prime, I don't really think I would need that. Why am I talking about that? Because they're saying the second degree of G. Don't I need G of 0 plus G prime of 0 plus G double prime? Well, do they?
G of 0 is negative 3, right? You see that?
Mm-hmm.
Yeah. So that's why I cancel out A, B, C. Turns out.
Oh, you went fast. Well, hold on. Let's see what happens. So when we... That's... Where are we finding it about? I don't know. She was guessing. Why did we guess 0? But what did you not pay, or me, pay attention to? That's why if you guys look at my FRQs, whenever you get copies of them, etc., to help you out, I underline anything that normally I would ignore, forget, look over, and I think has some sort of bearing to the problem. Doesn't mean you should. Some of you might get confused by that. But why does that make a difference? Well, so what's the one that definitely has to go away? A. So G of 1, well, hold on. How on earth can I possibly know G of 1? Oh, G of 1 is going to be, if I know this, shouldn't I maybe make G of x, which I think the AP would do a better job of, but make it from 0 to x of f of t dt? That's a better way of writing the accumulator function. Then if I need G of 1, can I find G of 1? Yeah. How? Going from 0 to 1, starting at your what is this? 1, 2, 3, 4. They said it's triangular. 4 and 4 is 16. Half of 16 is 8. I'm looking at 1. This is f, right? F of 1 is equal to 3. Like that one at least helps as far as getting here. Because then that should be 3 times x minus 1, which narrows this guy out. And then f prime of would be our second derivative, which would be our second term. F prime would be the slope, which is negative 1, right? Down 4, right 4. So this one, f of 1, which is 3, and then g double prime of 1 is equal to f prime of 1, which is negative 1. Negative 1 over 2. So the only difference is the original term. Right, but it can't be negative 3. I'm just trying to figure out why it's 1 half. It has to be a positive because my area is positive. Wait, I'm going to 1. 3. Oh, I'm going to 1. Okay. They didn't define the accumulator for a reason. I thought they just messed up. Sorry, on these packets, you never know exactly how great the questions are. So to get to G of 1, you do have to start with your initial, which is negative 3. But then you're adding from 0 to 1. I did the whole triangle for some dumb reason, which would be the rectangle go from 0 to 1 of f of x. is equal to 3.5. So negative 3 plus 3.5, g of 1 is equal to 0.5. There you go. I don't know why I did the whole triangle. Sorry, I should have stopped at 1. My bad. Yeah. Yeah. Wait, which one? Oh, no, you're good. For the nth term, the coefficient, find. Nice. Great question. Remember how I said a second ago? You have to remember that the coefficient is not just the derivative and vice versa, although I don't usually get tricked vice versa. This is a vice versa one. Because this one gives me the series, which I could go ahead and expand. I don't have to do all of them, though, because can't I just focus? Forget it. It's not going to get any better. Sorry, hold on. Can't I just focus on the third derivative?
Yeah.
So I can find the third term. Because that's an... Is that an n? Or no, it's just a triple prime. Oh, and the nth term.
Yeah. But yeah, it's the third time.
Wait, hold on. The nth term. Sorry, I'm just pausing. Because the nth term, first term, second term, third term, the first term would be the 0th derivative, right? The second term would be the first derivative. The third term would be the second derivative. The fourth term would be the third derivative. Maybe it is safer to plug in. Yeah. So the A1 plus A2 plus A3 plus A4 would match up with my f of 2 plus f prime of 2 over 1 factorial x minus 2 plus A1, A2, A3, f double prime of 2 all over 2 factorial x minus 2 squared plus f triple prime. Double check me, but I'm pretty sure it's the fourth term, yeah?
Yeah.
So in the fourth term, we would plug in 2 times 4 is 8 times 4 factorial all over 5 to the fourth. But careful, this is the coefficient, right? Because the coefficient equals the derivative over the factorial. So then I have to go ahead and say the third derivative of 2 all over 3 factorial is equal to 8 times 5 factorial. Sorry, 8 times 4 factorial all over 5 to the fourth. Multiply by 3 factorial. One, 2, 3, and 4. None of them would reduce with 5 to the fourth. All of them have 5 cubed. Dang. I thought I had it. It is a sub 3. Which means they must start at a sub 0. Didn't like that wording. So they make the first the 0th term, first term, second term, third term. I think it's a poorly worded question. Because the nth term, like in pre-cal, would be first, second, third, which this would have been the fourth. But, I mean, the nice thing is, guys, all of them are raised to the third power, right? Ours worked with the wrong term. Now, that's enough for this question, but once I think it was poorly worded. So a cubed. Because when you multiply by the 3 factorial, then you would get 6 times 3 factorial, which would be 3 factorial squared. Yeah? Yeah. Ugh, don't like that wording. It was a great question if they had just worded it a little bit better. Sorry, D. Because you would multiply. They combine. You see it? Yeah. You can look at it. Oh, yeah. We'll do FRQs beginning of tomorrow. That sounds good. The next packet's short anyway. Which one? What is negative 2x to the 4th over 5? I would have put B.
It's D, though. It's D. It looks so simple.
Oh, duh. Give me a second. It's the 4th degree term. It's not the polynomial approximation. That would be, this is the 4th degree Taylor polynomial, if you stopped right here. But it would have to have all the terms to be the entire approximation. It's not the 3rd degree. That would stop there. It wouldn't be the 5th degree, because that should go one more, which doesn't even, oh, it does exist. So then this by itself is the m plus first term of an alternating, wait. That's not alternating. It's the idea of the alternating, but I think once again, I think they made a typo. That should have been a minus. This would be all the terms up to the 3rd degree, all the terms up to the 4th degree, all the terms up to the 5th degree. This one is saying, hey, look to the m plus first if it wasn't alternating. That should be a minus. Where's my packet? I need to white out and make that a minus. All right. What are we trying for tomorrow? Logistic and Eulers. Guys, are we at least seeing that we have endeavors that we need to get more solid? Like, if we don't have the basics solid, we're not going to make it through all of their wording and tricky and what call it. You're supposed to be submitting these where? To me? No, please. I don't want them. Online, Google Classroom. Pictures of by 5 o'clock. Attempted graded. Do you have to have all the corrections worked out? No. Do you need to have the evens? No. But you're trying all of LTF number 2, okay? Because the copying, I need to figure out what happened on that. I don't know.